Okay, now we saw in our previous video, we saw the relationship between R and the density of a gas, and we arrived at the equation here, that the relationship between the density of a gas and then the universal gas constant is Pm equals dRT. So that is to say Pm is equals dRT, where M here is the molecular mass of the gas, and then of course P here is pressure, and then of course D is density, and then R is the universal gas constant, and then of course T is temperature. So now we have a question to calculate the density of chlorine gas at STP. Okay, so at STP, we know a standard temperature and pressure. We know that our pressure is 1 atm. Okay, the standard pressure is 1 atm, and then the standard temperature is 273 Kelvin. And then of course, what else? The molecular mass of the gas. The molecular mass of the gas for chlorine, one molecule of chlorine, which is Cl2, of course, you know, one atom is 35.5. So 35.5 times 2 will give us 71. So there is 71 gram per mole. That's the molecular mass. And then the only thing remaining is R, the universal gas constant, which we have in our previous video calculated to be 0.0821, then atm dm cube per mole per K. So if we put that into the equation, density is equals Pm divided by RT. So if we put everything into this, so we have 1 atm multiplied by M, so that is 71 gram per mole. So divided by R, which is 0.0821 atm dm cube, then per mole, then per K, then multiply by 273 Kelvin. So Kelvin we take off per K. So K raised power minus 1 times K. So this will go away. Then mole we take mole here. So this is per mole, this is per mole. So and then of course ATM will take ATM. And if you do this multiplication, if you have your calculator and you do 71 divided by this, so this will give us 71. The only thing we have here remaining is gram, divided by this 0.082 times 273 will give you 22.4133. Okay, that's what my calculator gave me. So this is gram, and then of course the only thing remaining here is dm cube. So dm cube, we are careful of our unit. So if you do this division, this will give you 3.17. Okay, 3.167. Okay, so which you can say 3.17, and then this is in gram per dm cube. And gram per dm cube can also be, you can also say 3.17 gram per liter. Okay, dm cube, liter are the same thing. 1 dm cube is equal to 1 liter. So of course you can see this is density, 3.17 gram per liter. So this is mass over volume, okay, which is density. So 3.17 gram per liter is the density of chlorine gas. The same thing for other gases. You can calculate density for oxygen gas, density for nitrogen gas, and then others, and compare them and find out.